Good morning, everybody. Welcome to Unit 3. Unit 3 is a long unit, and it's got some difficult stuff in it because this is the unit that we will be balancing chemical equations in, okay? Notice that you have quite an extensive list of vocabulary, so much so that I couldn't put the proficiency scale and vocabulary all on one slide. However, several of these vocabulary words are duplicates from past units. But make sure that you are studying the Quizlet set. If you notice, anything that is in that funny greenish bluish color and underlined has a link to it. So on slide 2, your Quizlet is linked to the title. So you just click on that link there to access your Quizlet, which you should have already done because we talked about on Tuesday how you would be doing Quizlet on Wednesday. Next up, you have your proficiency scale on slide 3. Again, look at all of those objectives. We're going to be doing a lot in this unit. Go ahead and click on slide 4. Now we're going to start highlighting information. Remember, to highlight the information, you have to click on where the words are. When you do that, a blue box will show up. When that blue box shows up, you also have new tools at the top that show up, including this handy dandy highlighter tool. So when I tell you to highlight something, you'll first highlight the text. Click the highlighter tool and choose the color. I don't care what color you highlighted in, as long as you can still read the words under the highlighter. We ready? All right, number 1, physical change. A physical change is a change that results in change in appearance or form. Highlight change in appearance or form. But not in the identity of the matter. An example. Pay close attention to these examples because those examples is where I get your test questions from. All right, look on the other side. Chemical changes. A chemical change is a change that results in a change in the identity. Highlight a change in the identity of the matter and keep going with those parentheses. A new substance with different properties is formed. Highlight that whole piece, starting with a change in the identity of the matter. And again, there are several examples there. Pay attention to those examples. I guarantee you're going to have a question that says, choose all of the following that represent chemical changes. And examples from this section and the previous section on physical changes are going to be listed. Okay? Number 2, a chemical change is also known as a chemical reaction. A chemical reaction is a change in matter that produces one or more new substances. You should already know a chemical reaction from your Quizlet set. That should not be a new thing. Number 3, chemical reactions occur when chemical bonds, attractions that hold compounds together, break, atoms rearrange, and new bonds form. Highlight that whole thing. Chemical reactions occur when chemical bonds, attractions that holds compounds together, break, and atoms rearrange, and new bonds form. Evidence of a chemical reaction. Again, highlight 1 through 5 there. You need to know those because you will have a test question that says, which of the following are evidence of a chemical reaction? Or all of the following are evidence of a chemical reaction except. Okay, so you need to know those. Next slide. It's going to be a minute. Endothermic reactions. Endo means into. Thermic means what? What is another word that you have heard that sounds like thermic? Thermo, thermometer, thermos. What do all of those have in common? Heat. Okay, so endothermic means heat heat is going into the reaction. Energy is removed from the surrounding and enters the system. Highlight, it feels colder. All right, so in endothermic reaction, you are going to start with, it feels colder to touch. You need to know that an endothermic reaction uses up the heat. That's what it means when it says heat goes into. It's using up the heat. So if it's using up the heat, how does it feel? It feels colder. And then number 5 is the opposite. Exo means out of. Thermic means heat. So exothermic reactions is when energy is released from the system and enters the surrounding area. So highlight, it feels hotter to the touch. Feels hotter to the touch. And it gives you a very good visual there that you need to pay attention to when we get to that point. Next page, slide 6. Periodic table reactivity. So last unit, we learned how to read the periodic table. We learned how to find information about each of the elements there. I think I have a hair in my mask because it keeps tickling my nose. Is that better? Awesome. Thank you, Allie. You're letting me record this whole video with my mask upside down, the rest of you. Okay. Periodic table reactivity, valence electrons are so important. If you don't learn about anything else, you must know what valence electrons are, or you're not going to get anything else in this unit. Because all chemical bonds, not all of them, but most of them depend on that number of valence electrons. Highlight, valence electrons are the electrons present in the outermost shell of an atom. In turn, the valence shell is the outermost shell of the atom. Atoms want to have a stable or full valence shell. Highlight that. This is the third bullet there. Atoms want to have a stable or full valence shell. When you looked at and built your atom models, you should have noticed the first shell always has 2 electrons in it. The next shell always has 8. And it has to fill up each shell as it goes out. The electrons in that outermost shell, you need to know how many electrons it can hold, and you need how many that are actually in that shell. And that's how you determine what other chemicals that element can bond with and what types of bonds it will have, which is what this unit is all about. Okay? So those valence electrons are very important. For the first energy level, a full shell would be 2 electrons. For the second and third energy level, a full shell would be 8 electrons. That's important. Highlight that in a different color than what you've highlighted everything else in. That's important because that's as far as we will go for this class. To the third electron shell, it gets kind of complicated and tricky, and there's lots of if-then statements as far as there's not a solid rule as far as how many electrons each layer will hold. So for the purposes of this class, we will not go past that third electron shell. So that gives you how many electrons each of those shells can hold.